Good morning, everybody. Maybe good evening, depending on when you are watching this video. I am Rama Venkat, Dean of Howard R. Hughes College of Engineering at the University of Nevada, Las Vegas, in Las Vegas, Nevada, United States of America. Some of you may know Hughes from the movie Aviator. He's a great entrepreneur, aerospace entrepreneur. He used to live in Las Vegas, and our school is named after him. If you really look at the first slide, the bottom of the first slide, it says educate, engage, inspire, innovate. And that's the mission of our college. We love to engage our students, educate them in all different kinds of ways, mainly in hands-on engineering education. We like to inspire them to be innovators and great engineers and designers. Of course, undergraduates and graduate students have plenty of opportunities to innovate working in the research labs. Today, what I'm going to do is to really present a couple of things for you and talk about what engineers do, what type of engineering, what type of job opportunities, and also what is UNLV Engineering, why UNLV Engineering, and what is the cost of attending UNLV Engineering. Those are the things that I'm going to discuss today. All right. First question is, what does an engineer do? Many of you may hear of the word engineering, computer science, all of that, but you may not know what engineers do. Engineers basically solve societal problems, any community problem. It could be a corporate problem that human beings face. That's what we try to solve. So given a problem, of course, when problem is given, it may have some challenges, some expected outcome. And of course, you have the constraints. That's what we call design constraints. Maybe cost is an issue, aesthetics is an issue, weight is an issue, power is an issue. What is the constraint within which you have to build the project? That's what you call design constraint. So when that's presented to an engineer, the engineer conceptualizes a solution. He comes up with a solution based on the constraints, the challenges, the deliverables, and the physics, the chemistry, the biology, the math, the basic science, the things, the way things work. And they conceptualize a solution. They design the solution, design the prototype. Of course, you simulate it. You don't want to spend a lot of money on a prototype without knowing whether it is going to work, whether the physical laws that you applied are going to work together. Is it going to make sense? Is it going to be structurally sound? Is it going to be safe? So you want to simulate it. There are lots of simulation tools nowadays available. They simulate them. And once we know it works, it's great. If it doesn't work, we tweak it a little bit. We then build it, test it, and of course, implement it. We manufacture it in some place and sell it in the market. That's exactly what engineers do. So what are the different types of engineering? There are many, many different types of engineering, right? You name anything, there could be an engineering. Biological engineering now, people talk about it, right? But traditionally, there are 4 or 5 engineering fields, and our college has 4 of them. I'm going to talk about them. Civil engineering, civil environmental engineering, if you want to talk about it, civil environmental engineering and construction. Civil engineers build bridges, dams, large buildings, roadways, water sewage systems, all infrastructure, airports. They build all those huge things. Of course, these are things that have to be safe. They have to work for what they're supposed to work on. So it's a very, very serious engineering field. The second one I can think about that my own engineering field is electrical and electronics engineering. Of course, the moment you see electrical engineering, you think about electricity. Of course, we need to generate electricity somewhere from a nuclear power plant or a gas power plant, coal power plant, or hydroelectric plant, renewable energy like solar energy, wind energy, geothermal energy. Of course, you generate this power. Wherever the electricity is generated, it cannot be used then and there. It has to be moved to a metropolitan area, maybe to a town, maybe to a railway station. So that's where power generation, power movement, that is what we call transporting the power from where it's generated to where it's needed, and all the electrical appliances that you can think about in a hospital, at a home, right? The washer, the dryer, the refrigerator, the microwave, the electric stoves, all of that need power. And of course, lighting, right? They've had lighting for the last 120 years or so. All of that require power. And then all the entertainment tools, right? The TV, the phones, All of that need power. All of that electronics, how it works, how the circuits make it to work, how the audio and video work. All of that is electrical in electronics engineering. The next type of engineering is what I call mechanical engineering. Anything that's a mechanical hardware, cars, aircraft, spaceships, elevators, escalators, air conditioners at home, coolers, nuclear power plants, anything that has a mechanical system behind it. Nowadays, there are human body parts, biomedical body parts. All of them are mechanical engineering. And without them, of course, we don't have physical infrastructure at homes. The next one is computer science. That is in my college, but some places computer science is part of College of Science and Arts. Sometimes they are in a school of computing. In our College of Engineering, we do have computer science. Of course, computer science is the brain behind most of the electronic stuff that works. All the computers, the TV, the phones, all the game consoles that all of you use, all of that require computing power, things to decide and deliver what you need, an audio or a video or some kind of a decision or control something. So that's what computer science is all about. Computer science really requires a lot of programming, coding, applications, and processing of the signal and making sense out of the data. So I talked about these 4 different types of engineering. Now let's look at employment opportunities. Of course, you can look at on the y-axis, you see the number of jobs. On the x-axis, you have all types of engineering. I mentioned there are at least, we are probably giving about 15 of them here. Look at that. All of them, the big ones are civil, industrial, mechanical, electrical, electronics, a lot of job opportunities in this area in the United States. The wages, if you really look at wages for electrical and computer engineering, most of them make, just an entry-level engineer makes $80,000 on an average. Of course, the computing fields are doing wonderfully well. There are a lot of job opportunities, a lot of salaries that are available for these students. So what type of employers can you think about? Civil engineers, you can think about large consulting companies, construction companies, public works board. Most of the cities have them, water treatment facilities, companies that build bridges, roads, all those kinds of things. And of course, you can work for city, state, and central governments. Electrical and electronics engineering, any company that makes phones, TVs, electrical appliances, GE, Samsung, you can think about Google and Apple, HP, Lenovo, Dell computers, all of them are electrical and electronic engineering job opportunities. Mechanical engineers, all car manufacturers, auto car manufacturers. You thought about Toyota, Honda, General Motors, Hyundai, right? There are Fiat. There are many, many, many companies. And then aircraft companies, Boeing, and companies like every country has now aerospace type of engineering opportunities, and space companies that send spacecrafts into the space. And also any company that make elevators, escalators, air conditioners, water coolers, all those things that have mechanical parts in them, the companies that make them, they are all great employers for mechanical engineers. Computer science, I don't even know how to talk about, right? There are so many computer companies, Google, Facebook, WhatsApp, Intel, Apple, HP, and every country has computer companies now embedded in them. What are the options for, other options for engineers? Of course, engineers, as I said, they graduate, they go work as an engineer or a computer scientist. They can go to graduate school. They can follow a master's degree, a Ph.D. degree, or maybe become a patent attorney. That's what I call Juris Doctor, JD, or become a manager, MBA. Those are all possible. If you follow and finish up a PhD, you can become a scientist, work for a national research organization or federal research organizations. Or you can become a professor like me, which is a great opportunity to educate people and change young minds and give them an opportunity in life. That's becoming a professor, teach and research and do service. Of course, you can become a patent attorney, become a manager. You love to create your own company. If you're entrepreneurial, you want to take a little bit of risk when you're young, yeah, you can create your own company or become a consultant. A lot of people become consultant, have a small consulting company. Guaranteed starting salary, 60 to 80,000. It can even be much more than that, depending on the area where you work. So Money and job, I talked about as engineer, that's important. For everybody, we need to have a job. We need to be able to put food on the table. Very, very important. Most importantly, I would like you to consider other things about engineering. It's very intellectually satisfying. You would be doing new projects every 6 months or 8 months, depending on the company. If you're an entrepreneur, you're seeking new ideas, new projects, new clients. So the opportunities to grow, continually learn in your profession for about 25 years to maybe 65, 70 years. There are a lot of opportunities to continually learn. Human beings are supposed to learn all the time. It should be exciting. Of course, it gives you a great opportunity to change the world. If you're working in environmental engineering, you worry about climate change. You are working as a civil engineer, transportation, you worry about safety of pedestrians. If you're working on as an electrical engineer, you are designing some new tools and sensors, so you can probably help people with disabilities. So there are lots of opportunities to contribute to the society, at the same time feel fulfilled intellectually. And also it's well-balanced lifestyle. That is, it's not crazy hours. Typically people work 8 to 5, maybe 5 days a week. Some people may work 6 days a week, but typically you work 40 hours a week, 50 hours a week, no more than that. So excellent, balanced life. So I have talked right now about what is engineering, what types of engineering, what types of jobs, and why engineering, not just money. There are other human life aspects that engineering contributes. So now I want to talk a little bit about UNLV Engineering. UNLV is a pretty young school compared to most schools that you hear about. It's only 64 years old. It was established in 1957. In such a young age, we have reached the highest status called R1 research status given by Carnegie Institution to the top 3% of the universities in the United States. This is like top 130 universities out of maybe 2,000, 3,000 universities, which means that we do a lot of wonderful things with research graduate, a lot of PhD students. We contribute to the innovation to the globe. Facts and stats about the university: 25,800 undergraduate, 4,200 graduate students, about now more than 130,000 alumni. We offer over 240 different majors and degrees and certificates. We offer BS degrees, BA degrees. We have combined degrees with master's and PhD. So we have MBA degrees, interdisciplinary degrees, so variety of different types of degree programs. About the college itself. Our college was established in 1988 and it was opened in 1989. And it has 4 main departments: civil, environmental engineering and construction. Computer science is part of our college, electrical and computer engineering, and mechanical engineering. The current enrollment in the college: 2,900 undergraduates, 300 graduate students. Of the 300, 150 of them are master's seeking students, 150 of them are PhD seeking students. College has 75 faculty members, and the degrees we granted last year, we granted close to 350 BA and BS. Master's degree, we graduated 36, PhD 28. We have 8 or so undergraduate degree programs, 8 or 9 graduate degree programs, and 4 PhD degree programs. And they're all listed here. You can kind of take a quick look at it. I don't want to go through all of them. I can share the slides with you so that you get to see what they are. All right, so why UNLV Engineering? Of course, engineering is there everywhere. In every country it is there. In the United States, many schools have that. There are about 300, 400 universities which offer engineering and computer science degree programs. But why UNLV Engineering? The one thing I'm very proud of is that UNLV College of Engineering is very diverse in terms of students, faculty, and staff. If you really look at our students, 30% of them are Hispanic students, a lot of Asian students from China, Philippines, and more than 20% of them are, about 20% of them are women. And if you really come and walk into our college, you will see a variety of different faces, interesting people. And of our faculty, they are from more than 20 different countries. They probably represent every continent on the globe other than North Pole and South Pole. So very different faculty. And our faculty are very well known in terms of their excellence in research and teaching. A couple of our faculty members have written textbooks which are used throughout the world. Dr. Jake Baker, Dr. Sarah Harris, their books are used everywhere. We have faculty members who are recognized in the top 1% of their research, about 8 of them. About 10% of our faculty are well known for research in their field. They are in their top 1%. One thing I love, I went to Indian Institute of Technology, Madras in India. It's a great hands-on program that I learned about 30 years ago. Our engineering college is very hands-on. It is not just learn theory, learn simulation. These students are in the lab doing some interesting experiments. They're doing a lot of projects as freshmen, sophomore, junior, and senior. As a senior, when they graduate, they do a capstone project. I've seen some of these projects. They're really working hardware of electrical and electronics and mechanical engineering, solving a societal problem. That makes our college really very unique, and I'm very proud of it. Excellent career opportunities. We have a dedicated career and internship coordinator who takes care of our students. We work with about 200 different industry partners, place our students in all kinds of internship opportunities. College provides plenty of service. Tutoring, we do mentoring, career planning, peer mentoring, industry mentoring, all kinds of opportunities so that you do not struggle when you go through education. And also, we are one of the most inexpensive and comprehensive program in the United States. I'll talk about the tuition and fees in a few minutes. So we are reasonably inexpensive for a high quality hands-on experience with known outcome of getting a very good job and a great learning experience. Of course, Las Vegas, the weather is very, very beautiful. It's a very welcoming global city with a lot of opportunity for entertainment. All kinds of cuisines are available in Las Vegas. Outdoor activities, plenty of them available. There are a lot of canyons to walk around in, go fishing, skiing, and we have a great international airport. There are flights to China and Europe and Central America and many other countries throughout the world from Las Vegas. You can just fly in and no issues at all. Finally, cost of attendance. Of course, parents are always interested in this number. Tuition and fees is about 28, 29,000. Living expenses, 20,000, about 48,000. I'm not sure. It could be that I asked that depending on the type of life you live. It could be 50. You can bring it down to 15,000. So anywhere between 45 to 50,000 is the cost of attendance per year, and it'll take 4 years to complete a BS degree in our college because 15 credits, total required credits is 120, 8 semesters. If you take some summer classes and smartly plan your study, you can probably finish it in 3.5 years and a summer maybe. The graduate programs, college offers many, many graduate programs. Cost of attendance is very similar to that. Both at the undergraduate level and graduate level, there are scholarships available to the student. There are graduate assistantship, teaching assistantships available to really good qualified students. So please do consider when you're applying for that. So my contact information is here. I've been dean for 11 years. I love it. I would love to see you in Las Vegas. Come to UNLV Engineering, and you will stay with us for 4 years and you're guaranteed a BS degree. If you come here for a master's, 2 years, you will finish a degree. For a PhD, it takes about 4 years. So I'm looking forward to having you here on our campus at UNLV in Las Vegas, Nevada, USA. Thank you very much. If you have any questions, you have my email, you have my phone number, send me an email or call me. I promise to answer your queries within 24 hours of receiving your phone call or your email. Thank you very much. Have a great day.